You know, in every single piece of tech we use, there are these tiny, unsung heroes working around the clock to make it all happen. From the big old components in a vintage stereo to the thousands packed into your phone, well, today we're pulling back the curtain on one of the most fundamental of them all, the resistor. And you're going to be surprised at the clever engineering packed inside these little giants. So let me ask you this. What's the invisible thread that connects your super complex smartphone, your big screen TV, and even your trusty old coffee maker? The answer, believe it or not, is usually smaller than a grain of rice, but its job is absolutely massive.
So here's what we're going to do. First, we'll break down exactly what these little things do. Then we'll meet the three main families of resistors and kind of get into what makes each one special. And finally, we'll see why picking the right one is such a huge deal for engineers.
Visit youtube.com/avidsystem and don't forget to subscribe.
And yep, the answer to that first question is, of course, the resistor. And its main job is really all about one thing: control.
I mean, its name kind of says it all, right? A resistor's whole purpose in life is to resist the flow of electricity. It's a passive component, which just means it can't add power or anything like that. All it does is get in the way, slowing down the current by turning that extra electrical energy into a tiny bit of heat.
Okay, the easiest way to wrap your head around this is with the classic water analogy. So, imagine electricity is just water flowing. A wire, that's a huge, wide-open pipe just letting it gush through. A resistor, then, is like a deliberate bottleneck, a narrow spot in that pipe. It restricts the flow, making sure that only the right amount of current gets to the more delicate parts of a circuit, like a tiny LED or a microchip. But here's the thing. Not all bottlenecks are the same. Just like a mechanic needs more than one type of wrench, an electronics designer needs different kinds of resistors. So let's meet the three main families. We're going to look at what I like to call the workhorse, the specialist, and the heavy lifter. Each one is built differently, and each one totally excels at its own specific job.
All right, first up is the most common type you'll probably ever see, the carbon resistor. You can think of this as the trusty, everyday hammer in the electronics toolbox. It's everywhere. And the way it's made is almost beautifully simple. It's literally just a mix of carbon dust, which conducts electricity, and a ceramic powder, which doesn't. By tweaking the ratio of the conductor to the insulator, manufacturers can dial in its resistance. The more carbon you add, the easier it is for electricity to get through. Simple as that.
Now, the biggest advantage here? They are incredibly cheap to make. But, and this is a big but, that comes with a trade-off. They aren't very precise. This is what we call tolerance, how much the real resistance can be off from what it's supposed to be. They can also be a bit electrically noisy. So they're great for general-purpose stuff where being super-duper accurate isn't the most important thing.
But what happens when good enough just isn't good enough? What if you need that pinpoint precision? Well, for that, you call in the specialist, the film resistor.
Okay, the way these are made is seriously cool. Instead of mixing powders, they take a ceramic rod and coat it with a super thin, perfectly even film of metal. Then, and get this, they use a laser to etch a perfect spiral groove into it. By controlling the exact path and width of that laser-cut groove, they can achieve an incredibly precise resistance value. It's amazing.
And this right here, this really makes it all click. A carbon resistor with a 10% tolerance is kind of like a recipe saying add about a cup of flour. But a film resistor with a 1% tolerance, that's like a scientific formula demanding exactly 100.0 grams. That level of accuracy is absolutely crucial in things like sensitive audio gear or medical equipment, where the wrong value could totally distort a sound or throw off a critical reading.
Okay, so we've got cheap and we've got precise. But what if your problem isn't either of those? What if you just need raw power? That's when you bring in the heavy lifter of the resistor world. These things are built like tanks. They literally take a special metal alloy wire and wind it around a tough ceramic core. Their whole job is to handle huge amounts of current, which means they generate a ton of heat. That's why you'll often see them physically bolted onto big metal heat sinks, just to help them stay cool.
Their superpower is their power rating. They can handle hundreds of watts, where other resistors would just, poof, burn out instantly. The downside? Well, that tightly coiled wire creates a little side effect. It starts to act like another component called an inductor. It's like a bonus feature you didn't ask for, and it can sometimes cause issues with AC circuits, especially at high frequencies. So it's an incredibly powerful tool, but a very specialized one.
So we've met the whole family.
Now let's just pull this all together and see how an engineer actually decides which one to grab from the toolbox. This table really lays it all out, doesn't it? You can see the trade-offs at a glance. For a simple little LED light in a toy, that cheap and cheerful carbon resistor is perfect. For a high-end audio amplifier, where every little detail matters, you've got to go with the accuracy of a film resistor. And for something really heavy-duty, like the power supply for a huge motor, only the sheer durability of a wire-wound resistor is going to cut it. So, at the end of the day, here's the crucial point. That humble little resistor is so much more than a simple part. Choosing one isn't just about a number. It's a critical design choice. It's a balancing act between cost, accuracy, and power. And getting that choice wrong, well, that can be the difference between a product that works for years and one that fails the second you plug it in.
It's pretty incredible when you think about it, right? How these simple components, all governed by pretty straightforward rules, make our incredibly complex world possible. It really makes you wonder, what other tiny giants are out there, just hiding in plain sight, waiting for us to understand them?
Thanks for watching.